Welcome back to another video. It's your favorite math professor here, Dr. Tarcia Hubert. And in this video, we're going to talk about a frequency distribution, okay? What exactly it is and how do you create one. That's what we're going to talk about. But before we talk about this, I just want to let you know that a frequency distribution is a way to organize qualitative data. It's one of the various ways that you can take qualitative data and organize it. Remember, qualitative data, we mostly think of words when we think of qualitative data, but remember, numbers can also be qualitative data. Anytime your numbers just categorize or it just puts it into categories or separates it, classifies it, then it's considered qualitative data. So your qualitative data, it classifies the data that you have. And so what exactly is a frequency distribution? A frequency distribution lists each category of data and the number of occurrences for each category of data. So remember, we just said that qualitative data puts the data into categories. Well, with the frequency distribution, you're going to show every possible category and the number that you have in each category. That's what a frequency distribution is. And then you can also have what's called relative frequency. This is the proportion of observations within a category and is found using this following formula. You're going to take the frequency divided by the sum of all frequencies, which is basically the total in your sample. So you're going to take the frequency for each category and divide it by the total number of your little n, which is the total number of things or people in your sample, or the things that you actually collected data on. All right, so that's your relative frequency, and that's how you find it. And then you can have what's called a relative frequency distribution, which lists each category of data with the relative frequency. So your relative frequency distribution is just a continuation of your frequency distribution. It adds an additional column and puts the relative frequency in it. I just wanted to cover these definitions first, but I'm going to show you exactly what it means. It'll probably make more sense once we look at an example, okay? Okay, so this is our example we're going to do. A phlebotomist draws the blood of a random sample of 50 patients and determines their blood types as shown in this chart over here. So this is the blood types of all the different 50 individuals that she drew blood from. Now what we want to do is we want to construct a frequency distribution. So in our frequency distribution, what we need to do is list out each type, blood type. We have blood type A, blood type B, blood type AB, and blood type O. And these are in no particular order. We just listed each one. And so now for the frequency, what we need to do is figure out how many of each one exists. So I'm going to go through this chart over here, and I'm just going to cross out each letter as I count it. That way I make sure I'm getting them all and I'm not duplicating any. So I'm going to start with blood type A, and I see one there, that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I see 18 of blood type A. So I'm going to write 18 here under the frequency. I'm going to do the same thing with blood type B. I see 1, 2, 3, 4, 5, 6. I see 6 of blood type B. So I'll come over here and write the number 6. I'm going to do the same thing with blood type AB. I see 1, 2, 3, 4. 4 of blood type AB. So that goes there. And then blood type O, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And I cross them out. That way I make sure I got them all and I didn't miss any, and all of them are crossed out. So I think I got them all. Another way I could check is that all of these numbers should sum up to 50 because there were 50 individuals in the sample. I have 18 and 6, which is 24. 24 and 4 is 28, and 28 and 22 is 50. So they do all add to 50. That's one way you can check to make sure you got them all. So I'm just writing 50 to let you know that's what they all add up to. So I could put a line underneath here so you can see. But this right here is your frequency distribution. So all you do is you list each category out with the number in each category. All right. And the next thing we want to do is we want to construct a relative frequency distribution. So basically, we'll do the same thing. We'll have our frequency, so I'll write those back on here, because your relative frequency distribution should also contain a column with your frequency. So we had 18 here. I'll put that back here. We had 6 here, 4 here, and 22 here. Well, for the relative frequency, what we have to do is use that formula to determine the relative frequency for each one. So for A, I would do 18 divided by 50. So 18 comes from the frequency of A, and 50 comes from the total number in the sample. So if you do 18 divided by 50, you end up getting 0.36. And so I will do the same thing for B. I will do 6 divided by 50. So 6 divided by 50, if you divide that out, you get 0.12. And then for AB, I will do 4 divided by 50. And if you divide that out, you get 0.08. And then for type O, we'll do 22 divided by 50. You divide 22 by 50, you get 0.44. Now, one way you could check your relative distribution is that your relative frequency, to make sure you have them all, is those should add up to 1. All right, so when you add 0.36 and 0.12, you get 0.48. And then when you add 0.08, you get 0.56, and 0.56 plus 0.44, you get 1. So those should total up to 1. Your relative frequency should. So this will be your relative frequency distribution. We got our frequency of each blood type, and then this is the percentage or the proportion. It's not a percentage yet, but we could change it to a percentage. But this is the proportion that each blood type is of the whole or the whole sample. All right. And then there's a few more questions that we want to answer. Let me see. So according to the data, which blood type is most common? And so you could just look at the numbers and see which one has the biggest frequency. That would be blood type O. So here we would write blood type O. And then according to the data, which blood type is least common? Just look at the frequency and see which one has the least. And that is blood type AB. And then use the results of the data to conjecture the percentage of the population that has type blood O. So if we look at blood type O blood, it's 0.44. But if we convert this to a percentage, that would be 44%. All right, so remember, this is a proportion. It can be converted to a percent. Now, this 44% of the sample was blood type O. Now, if we take that to make a conjecture about the population, or is this an example of descriptive statistics or inferential statistics? What do you think? If you said inferential statistics, then you are correct. So remember, inferential statistics is when you take results from the sample and you use that to generalize or make generalizations about the whole population, okay? So 44% of our sample was blood type O, and we're just going to use that and say approximately 44% of the population is blood type O. Now, there is a lot of other things that go with that, which we'll continue to talk about, but just in general, to just make a general conjecture using our sample, this is what we can say. All right. And so this is an example of a frequency distribution and also a relative frequency distribution. If you have any questions whatsoever, please don't hesitate to put them in the comments or reach out to me and send an email. Thank you for watching this video, and I'll see you in the next video.